So we're here at Display Week 2026.
Yes.
Please introduce yourself.
Yeah, I'm Frantz Lohier. So I'm French-American. I work for Amazon AWS. I'm part of the specialist organization. And so I focus on AI and robotics and physical AI. And today at the conference, we announced COOL. COOL stands for Cloud Optimized OpenCV Library. And OpenCV is this very large open source community that built the OpenCV library. And we went for the past year to optimize it on our on AWS Graviton chipsets. So Graviton are general purpose ARM processor, originally designed for data center operations, so like large in-memory database operations. But we came to realize that a lot of the baseline image processing algorithms and functions that OpenCV provides are actually nicely optimized for performance, but also cost on this particular Graviton architecture. And so for the past year, we went to actually port the library on this chipset, optimize it in a way where we are getting 20 to 30% performance boost, and while reducing the cost of running compute on AWS data centers. So today was the big announcement, the public one, in-person one, and so Satya and I were on stage to talk about how to use the library, where you can get it. There's also some open source benchmarking tool we released alongside the library, where I mean, if you want to actually measure the performance boost for your own computer vision pipeline, or also appreciate the cost benefits, you know, all that is free, and you can go and check it for yourself. So we're super excited.
It's really fascinating to understand how, for example, you and your team can optimize performance on these ARM server SoCs,
Yep.
because there's so much happening in the SoC, and it's like fourth, fifth generation coming, right? The
Yes.
Graviton. And I guess it has so many cores, and it's CPU. There's also other stuff, right, around the SoC.
Yeah, correct. So, and actually so Graviton is an ARM-based platform, but it's been largely optimized by the Annapurna Labs. So that's the acquisition that Amazon made back in 2015, I believe. And it's the fifth generation that's out. So it's a multi-core processor with very large cache and some unique ways we manage I/O. And largely because there's also another engine that we use in our data center that's called Nitro, which really is super efficient at managing hypervisors and input and output for very large processing clusters. So again, we thought it would be excellent for computer vision algorithms, but until today, we never really benchmark it, right? So that work is now down. There's there's a blog that was published that sort of went to all the measurement we did, so people can validate the methodology of measuring the speed up. And what else can I say? Yeah, and Graviton is so a general purpose processor. We also have co-processors, so Trainium and Infraria as our other chipsets that are being designed by the same lab called Annapurna Lab again. And those are more, so they need a host processor, and those are tailored for either training large AI models or inferring on them, right? So really three offerings that we don't open up again to the public. They are used for a lot of the managed services that Amazon offers. So we use that to actually run a lot of the software layers in our data center. Okay? So the fact that we went to work with OpenCV to accelerate the library on our own chipset and now opening that up is new. It's a new model for OpenCV, but it's one that we hear a lot of very large enterprise demanding. So, you know, when it's open source code, you think it's free, you think, you know, you can scale it until you are a very large company managing millions of large images, whether it's resizing, compressing, JPEG, decompressing. actually the compute required at scale globally in the world to do this stuff is very large, right? Until now, no one really took the time to map OpenCV on a large data center operation, and that's what we announced and did.
How much performance improvement or cost improvement could potentially be compared to doing stuff on GPUs? Does that make sense as a question?
Yeah, so the measurement we did for, so OpenCV has 2,500 algorithms now. It's a 5 million line of code, so it's been going on for 30 years, so very large, right? And so we focused on 70 core algorithms, and what we found was anything between 30% acceleration to 70%, okay? So that's quite significant. And in terms of cost, so we actually benchmark the cost benefit across our Graviton processors. And through this benchmarking framework I'm talking about, you can go and also benchmark yourself against other processor architectures. We are not focused, we looked at Graviton because we know this platform very well, but part of the roadmap is also to replicate the work we did on other platforms. If the customer wants a particular processor that we support in our data center, we'll be happy to also do proper optimization.
And people are designing new SoCs, and they could take this into consideration, how they might design a future SoC that does really cool stuff and accelerating all this, right?
Yeah, so OpenCV works also with ARM, the holding that sort of defines the instruction set. And combining some of the roadmap that OpenCV had access to, which is very much public information, combined with some of the insights that we gain them through the port on Graviton. There's some good learning, which I'm not going to comment here, but yeah, so I think the biggest takeaway is data centers optimized chipset are actually very good for computer vision tasks, okay? And so we think that we're going to have traction with this, not necessarily for small startup or do-it-yourself developers in their garage, but again, for large corporations that have a need to scale very large computer vision workloads, and also part of what was announced today is it's like a long-term support engagement from OpenCV. So similar to Linux, when large corporations go for a Linux kernel, they don't take the latest one, they want something stable and properly supported. And so through our partnership with OpenCV, it's not just a one-shot port on Graviton. The idea is to have something where a large corporation can say, hey, for the next 5 or 10 years, this library is actually officially sponsored by OpenCV, right? So, yeah.
And also, there's so much demand for GPUs. It's good to have an ARM SoC alternative to help fulfill the demand of the industry.
Yeah,
right?
Absolutely. I mean, GPUs are in demand for sure, but even regular chipsets. I mean, the explosion of AI, and there's an interesting connection between computer vision and AI. Computer vision is needed to do good AI, and AI is needed to do good computer vision, right? So we're seeing a bridge now, which is more and more clear, especially for physical AI topics, and the demand is exploding, right? So it's not only, that's why we use our Graviton processor for our managed services, but we actually support pretty much all the chipset out there in our data centers, right? So, yeah.
And if I can ask just a little bit about the use cases. So I like to play with my OpenClaw when I want to generate thumbnails that can recognize a person, change the background, stuff like that. But I guess it's all to do with like robots, self-driving cars. What use cases are you really great for on the cloud?
Yeah, so it's not just robotic systems. So part of the physical AI work we're doing, and we're starting to go public now, is also industrial inspection or warehouse automation or quantifying that someone on a production line is doing a proper job at assembling stuff. So it's not just robotic system, it's better simulators, better camera system to actually inspect what humans are doing. Okay, there's this big fantasy around humanoids we see everywhere, but we're taking a broader approach at understanding what physical AI means and how does that translate to data centers, whether it's hardware or software, that are better equipped to deal with the demand, because the demand is there. Okay, so yeah.
And it could be
Dernière question.
Last question. Last. So there could be a merge, kind of like a combination of edge AI.
Yes.
Together with the cloud,
Yeah.
when it makes sense, right?
Yeah. So what we see is this virtuous loop where you want to train those new models. We hear about VLA, VLM, all that, or word foundation models. You need to ideally collect a lot of good data. Not just simulated data, but real life data, and store that somewhere, do the training, which can be a lot of compute. And once you're happy with the model you've trained, we see the need to re-inject the model down to the hardware or the physical system and iterate on it until you have good quality, and quality is a wide definition. Is it accuracy? Is it speed? So it's a fascinating shift now where what we know for sure is what's going to happen in the cloud from a training perspective is going to be very demanding on data centers. And so we're happy about that.
Imagine every pixel, every sound, enabled through HDMI technology. From the highest resolutions, the fastest refresh rates, to immersive multi-channel audio, HDMI technology powers a worldwide ecosystem of devices for movies, for gaming, for creators. Experience clarity, performance, connection. HDMI technology. Connect the future today.